Hi Geometry, it is time to do our lesson on 9.1 circles and chords. If you are following along in the book, we are on page 366 and I've drawn this picture of this circle and this represents figure 9.1. So let's just take a quick look at some of the pieces in figure 9.1. First of all, you're going to see the center. The center is clearly located at point C. All right, the next thing I would like you to find is a radius. All right, let's see. I see a radius located at CX. All right, so segment CX is a radius. I see another radius at segment CR. I see another radius at segment CQ. Notice in a given circle, all radii are going to be congruent. So I'm going to go ahead and put my congruent symbols here. Now remember, if I was talking about the length of these segments, I would write the length of CX is equal to the length of CR is equal to the length of CQ. Now I could draw another radius somewhere in my picture. Let's just say I decided to go right here and I'll call this point P. Now there's also a radius at CP. So that's also congruent to segment CP, or equal to the length of CP. I could do that again. I could say right here, I'll make this H. I just drew another radii, or another radius, more than one radius is radii, at CH. So now I have another congruent segment at CH. Okay, all that being said, let's move on to our next item. Let's find a diameter. All right, looking for a diameter in this picture. A diameter has to go all the way across the circle and cut through the center. The only diameter I see in this particular picture is segment QR. So we have a diameter at QR. Now what about just a chord in general? Now technically there is a chord at QR, but I'm looking for a chord that is not a diameter. So the chord that I specifically notice is chord LM. Goes from one side of the circle to another without cutting through the center. So I'm going to call my chord LM. All right, one more thing. Let's go ahead and find an arc. There's an arc right here. This is arc LM. Now remember, I indicate my arc with this symbol, arc LM. Let's find another arc. Let's go all the way here with arc H. Go all the way here to X. Now this is a major arc, so I'm going to use 3 letters. I could call it arc HPX, or I could call it arc HRX. I'm just going to go ahead and call it arc HPX. And you can see that I go from H to X in this direction, and it's indicated right here in my arc naming. All right, let's continue. Looking at page 367 in your book, you wrote down in your notes, Theorem 9.1. In a circle, if a circle is perpendicular to a chord of the circle, then it bisects the chord. All right, let's take a look at how that looks in figure 9.3. So it says, in a circle, if a radius, okay, so my radius is OC. If a radius is perpendicular to a chord, the chord I am looking at is chord AB. All right, so is my radius perpendicular to my chord? Absolutely. You can see that 90-degree angle, which indicates that they're perpendicular. If that's true, it bisects the chord. That means it takes this chord, and as we definitely know from a previous video in geometry, bisects means cut into 2 equal sections, which means this section is congruent to this section. There was a D indicated here in my book, so I could then write that out as AD, segment AD, is congruent to segment DB because the length of AD is equal to the length of DB. And that makes sense because according to my theorem, when I have a radius that is perpendicular to a chord, it will cut that chord into 2 equal segments. We are now on page 368. I'm looking at Theorem 9.2. In a circle, or in congruent circles, if 2 chords, so this could be happening in just one circle or in 2 congruent ones. If 2 chords are the same distance from the center, the chords are congruent. All right, so let's take a look at our picture here. This is just like figure 9.4. All right, they're saying if two chords are the same distance from the center. All right, so I have a chord right here, QR. I have another chord right here, PN. Now they're saying that this chord is some distance, whatever this length is, AX from the center. And they're saying this chord is some distance, whatever this length is from the center. They're saying if that distance is the same. Okay, so I marked that with the 1 hash mark. So they're saying the distance from A to X is the same as the distance from B to Y. If that is the case, that means the chords are congruent, which that means that chord QR will be congruent to chord PN. And that's just because they are the same distance from that center of the circle. That means the chords are totally congruent. So if this length were, for example, 10, this length would be 10. If this length were 500, this length would be 500, as long as that distance from the center is the same. All right, now we're looking at page 369, and we are looking at Theorem 9.3. In a circle or in congruent circles, so same thing. I could be in just one circle or I could be in two separate circles as long as they're congruent, which means as long as they happen to have the same length for each radii as one another. All right, if the two chords are congruent, then they are the same distance from the center. This is exactly what we were just talking about in reverse. So now I don't know that these are congruent just yet. The only thing that I am given is the fact that this QR chord is the same length as this chord PN. Once I'm given that information, I know that segment AX is congruent to segment BY because that is the distance from the center to the chord. The center to the chord. You're going to notice in geometry, you're going to measure distance to something along a perpendicular angle. I'm not going to use this dashed line to measure the distance. This is a radius, and I do know that AQ is congruent to PB because these are congruent circles, which means they have congruent radii. But that's not how I measure the distance. You always measure distance in geometry from the center along a perpendicular to the line or wherever it is you're trying to measure the distance. So in this example, because my chords were congruent, the distance to the chord, you know what we'll call it the distance here. The distance AX is equal to the distance BY. Okay, if you have any questions on this, feel free to comment or to just contact me directly via email, Google Classroom, whatever works. In the meantime, you do have some classwork problems to complete, and hopefully this lesson made it a little more clear. Have a great day. Bye.